Nobody can see you, nobody can hear you. It's just my voice and the screen. Okay, so we're going to start graphing rational functions today, okay? So see in that box it talks about rational functions. Here's what I need you to know about a rational function, okay? It is a fraction with an x on the bottom. That's what a rational function is, okay? So everybody look at that equation right there, y equals 1 over x. That's kind of like the parent rational function. We're not going to do, you know, shift it and stretch it. We're not going to do anything like that with these. But if there were a parent rational function, that would be it, okay? Everybody in the room, tell me something that x cannot be.
0.
Can't be a 0, right? So x cannot be 0. The way we're going to restrict x from being a 0 is we're going to do an asymptote right there. Okay, the equation for that asymptote, it crosses the x-axis, so we're going to go x equals, where does it cross the x-axis? At 0. Okay, when you come to class on Thursday, it might be helpful if you brought a writing utensil that was a different color. I've never tried it before, but I think it might help you. I don't know. I just thought about it. I'm like, maybe they should graph in color. Maybe that would help them kind of, you know, just the different parts of it. Anyway, I'm going to graph this. We're going to graph this together by doing a table of values. We are not normally going to graph rational functions by using a table of values. A table of values is a very low-level way to graph something. But since we're just starting, we're just going to do this one. Okay? What if x was a 1? Then y would be 1 over 1, which is 1. What if x was a 2? Then y would be 1 over 2. What if x is a 3? Then you'd have 1 over 3. We're going to stop right there, and now we're going to plot those points. Okay, so everybody go right 1 up 1, make a dot. Right 2 up a half, make a dot. Right 3 up a third. If I went right 4, guys, how high up would I go? A fourth, and then a fifth, and then like 1 over 1,000, 1 over 1,000,000. Am I going to touch the x-axis? Yes or no? No. I'm going to get really, really close, but I'm not going to touch it. Okay? You guys see that vertical asymptote, that red line? It cuts your graph into 2. So you're going to have a piece of the graph on the right, and you're going to have a piece of the graph on the left. But the piece of the graph on the right is not done yet, okay? So what happens between a 0 and a 1? Like, what if x was 1/2? Can anybody tell me what 1 divided by 1/2 is? It's not a half. Good try. It's a 2. Look, everybody write this. 1 divided by 1/2. That's 1 multiplied by 2 over 1, right? And then that's just 1 times 2, which is 2. So you just flip it upside down, okay? So if I go right a half, I go up 2. If I go right a third, I go up 3, up 4, up 5. Am I ever going to hit that asymptote? No. Now, I didn't tell my last class this, but I want you to look. You have to be so careful. You guys listen. Every semester, I probably spend 10 hours at Weber State going through the rubric on how to grade this. And so I'm super good at it, and I know what they want. If you make your graph go like that, or even maybe like this, something like that, they're going to take off a ton of points, a ton. They're going to make me take off a ton of points because they don't think you really know what that asymptote means. So the asymptote means you get closer and closer and closer and closer to it, but you never actually touch it. So don't let it swing out, okay? So draw that in. That's only half my graph. So I have the right, but I don't have the left. I have to have something on both sides, okay? So I'm missing the left. Well, on the left side, the x's are all negative. So let's make those all negatives. So if I had 1 over -1, that would be -1. 1 over -2 is a -1/2. So all it does is just change all these signs. So now let's graph it. Left 1 down 1, left 2 down a half, left 3 down a third, down a fourth, down a fifth. The same thing happening on the other side is just coming from the bottom to the top. Be really careful that you don't do this. Look, don't swing that guy back down. He's not coming down, you guys. He gets closer and closer and closer to the x-axis. If it was a -1/2, it would be -2, -3, etc., and it's going to go like that, okay? There's one thing missing from my graph. Can anybody tell me what it is? Say it again. We do have to find the range. Yes, thank you for noticing that. There is a horizontal asymptote, Diego. You're right. Where is it? It's on the x-axis. Very good. So take your pencil, and I want you to dash in a horizontal asymptote. Okay. Now, that horizontal asymptote crosses the y-axis. So you're going to go y equals. Where does it cross the y-axis? At a 0. Okay. And now, yes, now we have to find the range. So everybody look at the graph. Range is y. Start low. Take your line. Go all the way up. Every person in the room, tell me the range. It's not everything. It's everything but 0. So we're going to say y cannot be 0. Please don't say x can't be 0. That's not it. It's y because it's range. Okay, question 1. Look at your paper. Step 1, factor. Okay, so let's do it. Everybody go f of x equals. Let's factor the top. So that factors to x plus 3 times x minus 3 over x plus 3. I have to ask you something. I want you to listen. If I were to cancel right now, could I cancel anything on that problem? Tell me. Yes, I could. What could I cancel? X plus 3's. Is that the next step that's on the list? No. What's the next step after factoring? Find the domain, which is what they're asking me. All you have to do is state that the bottom can't be 0. So the bottom can't be 0 means x can't be a -3, and we're done. That's all you have to do. Okay, let's do question B. Step number 1 on the paper is to factor. So you're going to go x minus 5. The x to the second splits to an x and an x. The 4 goes to a 4 and a 1. Signs are different. Biggest is the positive. So the 4 is the positive and the 1 is the negative. The next step on your list is to find the domain. The bottom can't be 0. So let's say x cannot be 1, comma, x cannot be -4. Okay? Now I'm going to say something about question 1. We're done with 1A, 1B. I want everybody to look at question 1. I'm going to see if anybody can answer this. If you can't answer it, it's okay. I just want to make a connection right here, okay? So I know on question A that x cannot be -3. I have to restrict x from being -3. I can restrict x from being a -3 in 2 ways. Does anybody know? How can you restrict it? No, good try. She said, let's start thinking about conjugate. Think about the graph. What can I put on the graph so that x is never going to be a -3? An asymptote. Yes, asymptote. Good, both of you guys. And it's actually a vertical asymptote, right? Because it's going to cross the x-axis. There's one more thing. Think of last year when you did this. What's the other thing? A hole is exactly right. Okay, so x equals -3 is either going to be a vertical asymptote or it's going to be whole. Don't worry about which one it's going to be. Just for this moment, I want you to know it's going to be one of those 2 things. Okay, let's go to vertical asymptote. If you look at your paper, vertical asymptote is all the way down to step 6. Okay, to find a vertical asymptote, it says take the bottom of the reduced equation and set it equal to 0 and decide if it's even or odd. We're not going to do the even or odd yet. We're just going to find it. Okay, look at your notes now. Vertical asymptote, you take the denominator and set it equal to 0. You can never cross a vertical asymptote. Okay, once you draw that in, guys, look, your graph can never come through. There, it's never going to touch it. It's not allowed to. Okay, let's do question number 2. Step number 1, factor. Done. Okay, Now we're going to, even though we're going out of order, we're going to jump right into vertical asymptote because that's what we're finding. You take the bottom and you set it equal to 0 and you get x equals -2. That's your answer. Literally, you're done. Listen what people say to me. This is important, so listen. Almost every single time I teach it, people say, well, now I'm confused because up on question number 1, you said it can't be that thing. And now you're basically doing the same thing and you're saying that it can be, okay? X can't be a -2. If X is a -2, you have a 0 on the bottom. So a vertical asymptote is a way of restricting X from being a -2. So draw an XY axis, come over to a -2, and draw in the vertical asymptote. I can never touch that vertical asymptote because X truly cannot be a -2. Okay? Who says gotcha? Let's see up high. I want to see how we're doing. Okay, I'm going to ask you a lot. Are you still with me? Are you still with me? So I'm going to give you so much material today. Okay? Okay, look at question B. Step number 1, factor. The top does not factor, so just write it down. The bottom factors to x plus 3 times x minus 3. Find the vertical asymptotes. They come from the bottom. So I have a vertical asymptote at x equals -3, and I have another vertical asymptote at x equals 3. You guys, when you're talking about vertical asymptotes, you cannot do this. You can't do x equals plus or minus 3. You can't do x equals 3 comma -3. Neither one of those is okay. You've got to write those separately. Okay, we're going to analyze them in a second, and we've got to analyze them separately. Okay, all right, let's draw a picture of this. Everybody draw an XY axis. Go out to a 3, and then go out to a -3. Tomorrow or Thursday, when you bring that different color, you're going to do a vertical asymptote right there and a vertical asymptote right there. Okay, I'm going to throw one more thing in to you right here. Okay, look right here. You're not going to do any graphing on your homework today. You're just going to find all these things. The fact that I have 2 vertical asymptotes cuts my graph into 3 parts. Like I have scissors. Scissors, scissors. I cut. So I have a piece over here, I have a piece over here, and a piece over here. So I'm going to have some kind of graph here, some kind here, some kind here. 3 pieces. Who says gotcha? Let's see. Okay, go back to the last one. Just tell me, how many pieces am I going to have to my graph on part A? 2 pieces. Okay, that's a big thing. Okay, let's do question C nice and slowly. Okay, everybody write h of x equals. The top does not factor. The bottom goes to x and x. You guys, does the bottom factor to 3 and 2, or does it factor to 6 and 1? Which one is it? It is 3 and 2, because 6 and 1 subtract to give you 5, and this plus right here tells me that I'm adding to get a 5. So that would be a 3 and a 2. Okay, the signs are the same. They're both negative. Find the vertical asymptote. You have to remember where vertical asymptotes come from. Where do they come from? The bottom. Yeah. So you have x equals 2, comma, x equals 3, and you're done. That's it. Okay? Let's do the next one. Factor. The top will factor. I'm not going to worry about factoring the top. Let's just pretend like it doesn't, because you're not going to have to know how to do it. The bottom does not factor. So how am I supposed to set the bottom equal to 0 if the bottom doesn't factor? Well, just set it equal to 0. So go x squared plus 4 equals 0. Then I bring my 4 over. X squared equals -4. Tell me what to do now, everybody. Square root it. And when I square root it, I get x equals, hi. Clarissa.
Can we borrow her for TCE?
Can you come back?
Yeah.
How about quarter after?
Quarter after?
Yes, 2:15.
Oh, we won't have time then.
It's up to you. You do what you want.
It'll only be like 3 minutes.
Okay, go ahead. You make the call, sweetheart. Okay, that's totally fine. I'm being nice.
Yeah.
We're just doing something really hard, and so it's her call, because she's,
Really quick.
you better. I'm timing you. Okay, square roots. So I square root. After the equal sign, what comes? Tell me. Plus or minus. What is the square root of a negative 4? What kind of I? Square root of 4 is 2. The negative gives me an I. Really? Am I going to try to graph an imaginary vertical asymptote? No. You can't see imaginary things, right, on your graph. They're not visible. So if it ends up being imaginary, then the vertical asymptote is none. Do I think that's going to happen on any of your quizzes or any of your tests? No, I do not think it's going to happen. Okay? Okay, now we're going to analyze our asymptotes. Okay, this is important. You have odd vertical asymptotes and you have even vertical asymptotes. Okay, so I want you to look at the difference. Look at the one that says odd. Look at the equation. If they asked you to find the vertical asymptote, we would say x equals negative 2, right? Grab your pencil and dash a line right there at x equals negative 2. Okay, now I want you to look. How many x plus 1s do I have? 1 on the bottom, right? 1. 1 is odd. So this vertical asymptote is odd. So right there I want you to put odd, and right there I want you to put odd. That's what I'm going to do for you when you come to class on Thursday. That's what we're going to do. Okay, everybody watch right here. Just watch, okay? My body is the vertical asymptote. My fingers are the graph. My hands are the graph, okay? So if I have a vertical asymptote, I'm going to have a graph over here and a graph over here. 2 pieces to my graph. Who says I understand what you're saying? Okay, great. Look what happens. I don't know what's happening. I do know this. If this is an odd vertical asymptote, as the graph approaches that asymptote, one goes up and one goes down. So it might be like that, or it might approach this way and it goes the other way. I don't know which one it is, but I know that they go in opposite directions. Who says I understand what you said? Great. Look at the other one. Even. Set x plus 2 equal to 0, you get x equals negative 2. How many x plus 2's do I have on the bottom? 2. 2 is even, so this is an even asymptote. Take your pencil, dash in a line at x equals negative 2 on both of those graphs. Okay, now I want you to watch again. Okay, watch me demonstrate this. Here's the asymptote. Here's the graph. The graph this is the number 2 reason, 2 or 3 reason that people cannot understand Thursday. Right here. So you're going to want to watch. Asymptote that's even. The graph goes to it and they go the same. So they both go up or they both go down. I don't know which one, but if it's even, I know they go the same. Who says gotcha? Let's see. Okay, yay. Now, go back to the problems up above, and we're going to decide if these are even or odd. Okay, so see this x equals negative 2? It came from this x plus 2. How many x plus 2's do you have? 1. 1 is odd. So that means one's going to go up and one's going to go down. Okay, this x equals negative 3 came from this x plus 3. The exponent's 1. That is going to be odd. Do you see why I'm having you write them separately? Because one might be even and one might be odd. And if you do the plus or minus thing, how are you going to differentiate? Okay, x equals 3 came from here. Exponent's 1. 1 is odd. Okay, let's do this next one. Question C. X equals 2 came from here. Exponent's 1. 1 is odd. Yes.
Is there ever going to be, like in the denominator, a 1 and a 2? If they're factored?
Say it again.
One's squared and one's just...
Sure.
So what
Sure.
would the end behavior be then?
Let's go a step at a time. Is that okay? I'm afraid if I address it right now, I'm going to freak you out. Well, maybe it won't freak you out. I'm going to freak everybody else out. So, will you remember that question? Okay, because all you have to do, honey, is you just go step by step. We haven't even done end behavior yet today. End behavior is a non-vertical asymptote. We haven't even gone there.
Will it be odd or even?
Okay,
They're
so
both
if,
yeah.
so if this was squared, this would be even. If this was first, this would be odd. So you look at the exponent that's with the thing that gave you the solution. You good? That was a good question. Okay, that wasn't a 2. So just on your notes, that is odd because the exponent was really a 1 right here. Okay, but that's what you do. Did I answer your question? Okay, good. I'm glad I got to answer it. Okay, so this one said none. Okay, so that's it. Yes, sir.
So if that happened, would it have to be like a graph that has 3 different parts?
It would, whether, if this was a 2, is that what you're saying?
Yeah.
If this was a 1 or a 2, I'm going to have different parts anyway, because I'm going to have a positive 2 and a positive 3, and so I have 3 parts regardless if it's even or odd. Does that make sense? I like your question though. Good question, buddy. Okay, now we're going to talk about end behavior. Okay, now I need to change my notes. There's going to be a lot of me overwriting things because of how Weber has changed what they're doing. So up above this box, I want you to write non-vertical asymptote. That's what they're going to ask you. They're going to say, find the vertical asymptote, find the non-vertical asymptote. Okay, a non-vertical asymptote is a horizontal asymptote or an oblique asymptote. Okay, and then in parentheses, I want you to say never both. You're never going to have a horizontal and an oblique. It's a horizontal or an oblique. You're going to have one or the other. They're both non-vertical asymptotes, and they're both end behaviors. Okay, remember the arrows we did last time, right? That tells me where to go. That's what we're doing right now. Okay, non-vertical asymptote is an end behavior. Okay, let's talk about horizontal asymptote. The first thing I want you to decide is this a horizontal or is it an oblique? So the way you decide if it's horizontal is biggest over biggest. You're going to have to memorize that. Okay, what biggest over biggest means, take the biggest exponent on the top, take the biggest exponent on the bottom, and write them down. Okay, now right here you have 2 options. You can memorize this or you can figure it out. I never memorize it. I always just figure it out because I can, and you guys can too. So it's up to you. You deal with it how you want to deal with it. If the exponents are the same, the top equals the bottom, y equals, I want you to cross that out, and I want you to put in the word simplify. Okay? If the bottom exponent is bigger than the top, then the horizontal asymptote, which is the non-vertical asymptote, is y equals 0. If the top exponent is bigger than the bottom, then the horizontal asymptote is none, and you have a slant. Slant and oblique are the same thing. Okay? All right, let's go ahead and do this nice and slowly. Actually, one more thing I want to say to you. Add a little example right here, and just draw an XY axis. Okay? I want you to go up 2, and I want you to draw in a horizontal asymptote. That would be your non-vertical asymptote. Okay? What I need you to understand is you can cross a non-vertical asymptote. You can never cross a vertical. A non-vertical or some kind of an oblique, you can cross it. So I need you to take your eraser and I need you to get rid of the center. So when you draw a horizontal, you're only going to draw the far right and the far left. The middle, we don't know. We're going to figure it out. Okay? A non-vertical asymptote is an end behavior. Look at my graph. All that horizontal asymptote tells me is this. Look, guys, as x gets really big, my graph goes there. As x gets really small, my graph goes there. That's what it tells me. The middle stuff, I'm going to figure it out. We're going to play, it's like playing Sudoku. It's like a puzzle, what we're going to do next time, okay? Okay, here we go with question 3. Find the horizontal asymptotes. Biggest over biggest. Everybody write y equals. The biggest exponent on the top is a 1. Write that whole term. So write down 5x. The biggest exponent on the bottom is a 1. Write that whole term. You guys, this is the easiest scenario. If the exponents are the same, you simplify, meaning the x's cancel. So your non-vertical asymptote is y equals 5. Yes, it's a horizontal, but a horizontal is a non-vertical. Draw an xy axis. Go up to a 5 and dash that in, leaving the center open. So now what I know is as x gets big, it goes there. As x gets small, it goes there. That's what I figured out so far with that. Okay, yes, go ahead, honey.
Sorry, what, like, why did you not put the 2 under the 5x over x?
Because the 2 doesn't have the biggest exponent. The biggest exponent is a 1. So I disregard that and I take my biggest exponent. Did I answer your question? Okay, yes. You okay? Okay, let's do another one. We're just going to do little baby steps, okay? Biggest over biggest. Y equals 2x to the second over 4x to the second. You guys, this is still the easiest scenario because they're the same. So look how easy. You just get rid of the x to the seconds and you get y equals, tell me, 1/2. Good, that's your answer. Today, you don't have to graph, but we're going to graph on our notes because I don't want you to freak out on Thursday, okay? So go up to a 1, take your pencil, and dash at a 1/2. Do the right and do the left, but don't do the middle. Why don't I do the middle? It might cross through, right? It might cross through. Okay, question C. See if we have a horizontal asymptote, basically is what they're saying. Biggest on the top, 2x. Biggest on the bottom, x squared. You have 2 options. One option, memorize. Look right here. The bottom is bigger than the top. So the non-vertical asymptote, or the horizontal asymptote, is y equals 0. If you haven't memorized, you're done. Okay? I'm going to show you how to figure it out. All the work that I show you right now, I want you to write down, but you wouldn't have to write it down if you were figuring it out. You could just like start thinking about it, okay? Look, if I reduce this x cancels with one of those, so that would reduce to 2 over x, okay? You guys, a horizontal asymptote is an end behavior. It tells you where your graph goes as x gets big and as x gets small. So let's make x get big. Let's go 1, 2, 3, and then let's do 1,000. Okay? So if x is a 1, 2 over 1 is a 2. If x is a 2, 2 over 2 is a 1. If x is a 3, 2 over 3. If x is 1,000, 2 over 1,000, which is the same thing as 1 over 500. How about 2 over 1,000,000, right? That'd be 2 over 500,000. What is my y getting really, 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 really close to? 0. Yeah. So if you have more x's on the bottom, when the x's get bigger, the y's get smaller. They get closer to 0. Who says I get that? Raise your hand. Okay. So memorize it or think about it. It's up to you. Look at question D. If we were checking if we had a horizontal asymptote, biggest over biggest, x to the third over x to the second. If you reduce that, you would get y equals x. Y equals x is a line. Is that horizontal? Is a line horizontal like that? No. So the horizontal asymptote would be no horizontal asymptote. And on this problem, we're going to have an oblique asymptote. Okay? Now, we're not going to find the oblique yet. That's our next step. But I'm trying to show you that on this one, the non-vertical asymptote is actually going to end up being an oblique. Okay? Who says gotcha? Let me see how you're doing. Okay, great. Lots of information, you guys, but you're smart enough. You can do this. Okay? I know you can do this. Okay, find an oblique. If the top exponent is bigger than the bottom, then the non-vertical asymptote is an oblique. Everybody write non-vertical asymptote. If it's not a horizontal, then it's oblique. Here's what you do. You divide. To find the non-vertical asymptote, you take the bottom and it goes on the outside of the division symbol, and on the inside goes the top. Okay? Two things I want to say. Fill in what's missing and the other thing I want to say is drop the remainder. Okay? Question 4, nice and slowly. Find all the asymptotes. There's only 2. You've got vertical asymptote and non-vertical asymptote. Don't look at your paper I gave you. Try to remember. How do you find, well, first of all, let's start over. What's the first thing you do? You factor, okay? The top doesn't factor. I can look at it and tell, actually it does factor. It factors. Everybody go, f of x equals 2x, plain x. The 1 goes to a 1 and a 1. Signs are the same. They're both positive. That gives me a 3x. I'm good. The bottom is x minus 1. Everybody tell me, how do you find a vertical asymptote? Where do you look? The bottom. If you just said bottom, that's awesome. That was like 15 minutes ago, and you still remember. Okay, that's good. Set the bottom equal to 0, and you get x equals 1. Even or odd? Tell me that. Odd is correct. Let's write down odd. Non-vertical asymptote. It's either a what? Tell me. It's an oblique or, talk to me, horizontal. Which one do we check for first? Horizontal or oblique? Horizontal. How do you find horizontal? Come on. I always go like this. Biggest over biggest, right? Biggest over biggest. That's okay. That's all right. You're going to get this. Biggest over biggest. So the top is a 2. The bottom is a 1. The top is bigger than the bottom. What's the horizontal asymptote? There is not one. That's why the original, well, it didn't say find all the asymptotes. Anyway, there is none. If the top is bigger than the bottom, there is no horizontal asymptote. So now I have an oblique. Take the bottom of the fraction, x minus 1. Divide it into the top. Everybody freeze for 2 seconds. This is a problem. Do I use this numerator or this numerator? A or B? A. B is silly, right? It's factor. You can't put that in there. So you put it on the inside. 2x to the second plus 3x plus 1. Now I'm going to do long division. Here we go, nice and slowly. What do I multiply by x to get 2x to the second? That's 2x. People get confused right here. I take the 2x and I distribute it to an x minus 1. When I do that, I get 2x to the second minus 2x. Tell me what to do now. What do I do? You don't draw the line. Well, you could draw the line. But what's the next big thing? You got to change those signs, right? I change the signs and then draw the line. It doesn't matter. Just make sure you change the signs, right? The 2x to the seconds cancel. 2x plus 3x is 5x, right? Tell me what to do now. Bring down the 1, and then you start the whole thing over again. What do I multiply by x to get 5x? That would be a 5. Distribute. and I get 5x minus 5. Tell me what to do now. Change the signs, and I get a 6. Talk to me about that 6. It's the remainder, right? There's nothing else to bring down. And up here we said throw out the remainder. So the 6 is gone. So your non-vertical asymptote is y equals 2x plus 5. It ended up being an oblique, not a horizontal. That's it. Okay, who says I'm still with you? Okay, we're going to draw it. Do you have to draw it on your homework? Nope. But I don't want you to have a freak out on Thursday. Go to x equals 1. Take your pencil, dash your line. Why is that guy solid? Because it's a vertical and you can't cross it. So I'm making it solid. Do not touch that. How many pieces am I going to have to my graph? I'm going to have 2, right? Everybody go up 5. Make a dot. The slope is 2 over 1. So I'm going to go up 2 right 1, down 2 left 1, down 2 left 1. Okay? Then I'm going to dash it. Let's extend that over here so I can see a nice intersection. But that oblique replaced the horizontal, right? It's either going to be horizontal or oblique. And remember when I did horizontal, I never filled the middle in. So same thing here, I'm not going to fill that middle in. So what that oblique asymptote tells me is that x gets really big, my graph is going here, and as x gets really small or vice versa, then my graph is going here. The middle part, I'm going to figure it out. Okay? Who says I understand? Man, if you can understand this, Thursday's going to be so much better. Does anybody want to say anything about how I drew this? Anybody want to say anything? What do you think?
I just don't really get like why you draw it. Like you say like when you get big, like what's the point of drawing?
Okay, so the point of a horizontal or a vertical, the only reason you care is end behavior. So if you're like this and x gets small, I know my graph is going down. As x gets big, my graph is going up. Sounds just like the last lesson we did, right? So I know my graph is like this. That's end. Middle, I don't know. But I know my end is like this. You with me? Okay. Anybody else? Comments or questions? Okay. Nobody made a comment about that? That's okay. We'll do with that next time. Okay. I just wanted to see if anybody was going that far. Okay, here we go. Find the oblique or the slant. We're going to do more than that. We're going to do vertical asymptote and non-vertical asymptote. Step number 1, factor. Done. Step number 2, vertical asymptote. Tell me one word without looking at anything. You make your brain work. Where do I look? The bottom. And I get x equals 3. Even or odd? Everybody tell me. Odd. Non-vertical asymptote might be a horizontal or an oblique. The first thing I'm always going to check is horizontal. Biggest over biggest. That would give me y equals x squared over x. You don't even have to write that down if you don't want to. The top exponent is bigger than the bottom, so the horizontal asymptote is, tell me, there's not one. So now I know it's oblique, so now I know I have to do long division. Okay, on the outside goes an x minus 3. On the inside goes an x to the second. Nobody say anything for a minute. Okay, you guys are so wonderful. I have to preface this with don't say anything for a minute. Okay, write down what I write. Okay, what do I multiply by? I skipped over something a minute ago, but it's okay. You won't know what I'm doing wrong. And I want you to write down, because it's not so wrong that I don't want you to write it. What do I multiply by x to get x a second? That would be an x. Distribute the x, and I get x to the second minus 3x. Just 1 second. Distribute, I get x to the second minus 3x. What do I do now? Come on, what do you do? Remember, the next thing is change the signs, right? Those cancel, and I'm looking at that going, this is weird. And then people sometimes even write down the 3x.
I need Ann Silos down to the office for a second.
Okay, can she come, does she have to come this second?
What?
Can she come in like 10 minutes?
Yeah.
Okay, thanks. So people go, that's a remainder. I'm going to throw it out. My answer is y equals x. That's wrong. Why? Tell everybody.
Can you put a 0 in here, right?
Yes, so I skipped over this last time, okay? I skipped over it right here, so look right here. See how you have an x to the first out there? You have to have an x to the first and a constant, which I do. On the inside, my biggest is a 2, so I have to have a 2 and a 1 and a constant, which I do, so I'm good. Look at this one. Outside, I have an x and a constant, so I'm good. Inside, I'm missing things. I've only got a squared. I'm missing a first and a constant. So how do I fill those in? Plus 0x plus 0. They must be there, and this actually came up on a midterm where a lot of my students missed it because they all wrote y equals x. Not a lot of them, but some of them, because they didn't fill in. Is 3x my remainder, everybody? No, what do I do now? Bring down the 0. Then you start again. What do I multiply by x to get 3x? That would be a 3. Distribute. I get 3x minus 9. Change my signs. First terms cancel. I get a 9. And the 9 is a what? A remainder. So my non-vertical asymptote is actually y equals x plus 3.
How'd you get plus 9?
Say it again.
You got negative 3x.
A lot of people struggle with that. So how do I get these? I took the 3 and I distributed it to x minus 3. That's 3x minus 9. Change the signs. That's what I have right there. You okay? All right. The last thing we're going to talk about is a hole. Well, we've got vertical asymptote, horizontal asymptote, but we've done those before. I mean, x-intercept, y-intercept, but we've done it. Okay, let's talk about a hole. The only way you're ever going to have a hole is if something reduces. Write that down. If it reduces. If you have a hole, you're going to write it as x comma y. Okay? I do want to tell you this. There is just about a 0% chance of Weber state giving you a rational function that has a hole. If I could say 0, I would say 0. We've done this now through Weber for like 6 years. They've never given us a hole. Not one time. I'm going to give you holes on everything I do because I have to make sure you know, but I don't think you're going to see it from Weber. That would be my guess. Okay? Here we go. We're going to follow this paper now. Okay? Here we go. Step number 1, factor. Here we go. Everybody write f of x equals, factor the top, x plus 1 times x minus 1, pardon me. X plus 1 times x minus 1. Factor the bottom. It goes to an x and an x. Signs are the same. They're both positive. 2 and 1. Multiply to give me 2 and add to give me 3. Does something reduce here, guys? Talk to me. Yes, it does. Is reduce the next thing that's on my list? No, don't go out of order. What's the next thing? Find the domain. Try not to look at the paper. How do you find the domain? The bottom. So x cannot be equal to -1, -2. I know that it's acceptable to write your domain like that. I asked them specifically. Step number 3 on my list, reduce. This does reduce. X plus 1 cancels with x plus 1. Now watch this. If you take x plus 1 and set it equal to 0, you get x equals -1. That is the x coordinate of my hole. Okay? I'm going to skip over whole, and I'm going to go to 5 for just a second, write the reduced equation. The reduced equation is f of x equals x minus 1 over x plus 2. Okay, this is important. Read step 5. Read step 5. Use this equation to find everything else. Maybe take your pencil and box it, or take your highlighter and highlight that phrase. Use this equation to find everything else. Don't do this to your paper. I'm going to do it to mine though. Look, this original equation is gone forever. This original equation is gone forever. And this is what I'm going to use to find every single thing else. Okay? Okay, let's go to vertical asymptote. That's number 6. How do you do it? Bottom equals 0. So I have people that go x equals -1, x equals -2. That's wrong. Why is it wrong? Where are they looking? They're looking at those ones I scribbled, right? You're supposed to look at the original. So the only vertical asymptote we have is x equals -2. And by the way, that's an odd vertical asymptote. Okay, I hate the way that's written. It's not mathematically correct. Vertical asymptote, maybe put a colon right there. That's correct now. Okay. Okay, let's go back to whole. I'm kind of jumping around. How do you find the y coordinate of the whole? Plug in the x. Yeah, plug in the x. So everybody go f of -1 is equal to -1 minus 1 over -1 plus 2. That's a -2 over a positive 1, which is a -2. What haven't we found that you know how to find, that we've gone through? What's the only thing we're skipping here? Well, you don't call it horizontal. What do you call it? Non-vertical. So let's all go non-vertical asymptote. It might be a horizontal, but it might also be a, tell me, an oblique, right? Or slant. Okay, let's check horizontal. Biggest over biggest. I would have y equals x over x. What does that give me? Some people said y equals 0. 0. Is that 0? Is 4 over 4 0? If you have the same thing over the same thing, that would be a 1. So your non-vertical asymptote is y equals 1. We're done with the problem. But we're going to do a little pre-graphing. Okay, we're going to just take a sneak peek into Thursday. Okay, draw your XY axis. Yes, sir?
To find the whole, where did you get the -1 from?
It's what canceled. See the x plus 1? Set that equal to 0, -1. You okay, buddy?
Yeah.
Okay, vertical asymptote, y equals 1. I always start with my asymptotes. Dash it in. Leave the center. Oh, I did, oops, I messed up. Oh, I did it okay. Yeah. Non-vertical asymptote is y equals 1, which is right there. And I'm going to leave my center open. The non-vertical asymptote is -2. So I'm going to come over here to a -2, and I'm going to dash that in. Okay, so I've got my asymptotes. Now I know I have a whole at -1, -2. So I'm going to go to the ordered pair, -1, -2. I'm going to make an open circle right there. That's all I have so far. What else do I know? I know that this vertical asymptote is odd, so I know one's going to go up and one's going to go down. I also know my end behavior is going to be this like this and that like that. It's the middle that I've got to figure out. How many pieces am I going to have to my graph? Tell me that. How many pieces? 2. One on the right, one on the left. Okay? Who says I'm good so far? Let's see, raise your hand. This is going the best it's gone today, I'm just telling you. Think I'm getting better. Okay, 7 and 8 and then we're done and we have about 9 minutes to get through it. Okay? To find the y-intercept, let x be a 0. You guys know this. 0, comma, some number, done. Easy. To find an x-intercept, you're going to let y be a 0. 0 in the y and some number in the x. Okay? Now, I'm going to explain something to you. This is important. It's going to save you some time And I want you to watch, okay? Add a little example right here. Y equals 4x over x plus 1. Now let's make it easier, erase the 4. Let's just say x over x plus 1. If they ask you to find the x-intercept, you say, okay, x-intercept, I'm going to let y be a 0. So I'm going to go into that equation, and I'm going to have 0 equals x over x plus 1. Now I want you to listen. I have a fraction equal to 0. The only way a fraction is ever 0 is if what? If say it again.
Everything else is 0.
Is it everything else?
Bottom is 0.
Is it the bottom? When do you get a 0? It's the top. It's the top. So just listen for a second. 0 over 7. 0 over negative 52. 0 over 364. Every single one of those is equal to what? 0. So you take the top of the fraction and set it equal to 0. So it's so easy. It can save you so much time. Look, set the top equal to 0. I get 0, 0. It's odd, so I know it's going to cross. Okay? Okay, now let's do question 7. Find the x-intercept. I'm going to let y be a 0. To find the y-intercept, I'm going to let x be a 0. You guys, I'm going to say the same phrase 5 times right now. And you're going to start saying this in your mind. You're bugging me. You're annoying me. And I hope I annoy you. That will be like, yes, I'm bugging them. Because then, because then you're going to remember. You're going to go, what's that annoying thing she keeps saying 15 times? Oh, yeah. Then you'll say it in your brain. Okay, here we go. To find the x-intercept, I let y be a 0. Which is the same as letting the blank be a 0. That's the annoying phrase I'm going to say 15 times. Letting the blank be a 0. What's the blank? I'm going to say it again. To find the x-intercept, you let y be a 0. Which is the same as letting the what be a 0? Tell me. The top. Everybody in the room say top. Top. Can 2 be equal to 0? No. 2 apples is never going to be the same as 0 apples. Okay? So if it's something that doesn't work out, just fill in the word none. To find a y-intercept, look how easy, you guys. To find the y-intercept, you just take away this x because it would be a 0. Then you'd have 2 over negative 1, which is negative 2. That's it. Okay, let's do the next one nice and slowly. Let's factor first. Step number 1, when you do these all together, is always going to be to factor. So factor the top, factor the bottom. Two numbers that multiply to give you 6 and add to give you 5 are 3 and 2, and they're both negative. Okay, to find the x-intercept, you let y be 0. To find the y-intercept, let x be a 0. To find the x-intercept, I let y be a 0, which is the same as letting the blank be a 0. Every person fill in the blank. The top. So everybody go 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. That's the x-intercept. Now I'm going to say something, another thing that's important. So many details. Look right here. Here's an equation right here. Here's an equation right here. Top, bottom. They're the same thing. One of them factored, one of them's not. If I'm trying to find the y-intercept and let x be a 0, I'm going to get the same answer no matter which one I use. Which one of those, top or bottom, is going to be way easier to let x be a 0? The top. Look. 0, 0, 0. What am I left with? It's right there. 1/6. That's it. Okay, let's do another one. Step number 1, factor. R of x equals x plus 2 times x minus 2 over x minus 1. To find the x-intercept, let y be 0. To find the y-intercept, let x be a 0. Here comes the annoying phrase again. To find the x-intercept, you let y be a 0, which is the same as letting the blank be a 0, fill in the blank. The top. Set x plus 2 equal to 0, negative 2, crosses. X minus 2 equal to 0, that's 2 comma 0, crosses. You tell me, equation A or equation B? I'm trying to let x be a 0. It doesn't matter where you go, but one's easier than the other, so why use the tough one, right? So if I can teach you, which one's easier, A or B, to let x be a 0? A. Do you see this? Look, if x is a 0, that's a 0, that's a 0, your answer's staring you right in the face. It's a 4. If I do this one, look what I do. 0 plus 2 times 0 minus 2 over 0 minus 1. That's a negative 4 over negative 1, which gives me a positive 4. That's way tougher than going slam, slam, look. Okay? Who says I understand? I got the same answer either way. Okay. Last one. Cross out 8. We're not going to do that. We're going to do this. Here's our new example 8. Okay? F of x equals x plus 1 over x to the second minus x minus 6. If you can watch me do this problem, and you're like, I get it, I get it, I get it, all the way to the end, I feel good. I feel good about where you're at. If you're struggling or if you're spacing out, I don't feel so good. Okay, take your paper, let's follow it. Okay, step 1, factor. Here we go. The top is factored. The bottom, x and x. 6 goes to 3 and 2. The 3's a negative. Step 1 is done. Look at your paper. Tell me the domain. The domain is, where do I look to find the domain? The bottom. X cannot be equal to negative 2, comma 3. That's going to be an answer. Reduce. Does anything reduce? No. The next step is whole. Do I have a whole? No, because nothing reduced, right? Now I'm to step 5. Write the reduced equation. I still don't have anything to write because nothing reduced. So now I'm down to step 6, which is vertical asymptote. How do I find a vertical asymptote? Tell me. One word is all I want from you. Bottom. Look right here. Yellow, pink. They are the same equation. One of them's easier. Which one's easier to let the bottom equal 0, yellow or pink? Which one? Come on. Pink. It's already factored for you, right? Set that equal to 0. You get x equals negative 2, and that would be odd, by the way. The next one is x equals 3, and that would be odd. Okay? On your paper, the next step is x-intercept. To find the x-intercept, you let y be 0, which is the same as letting the blank be a 0. What's the blank? The top, negative 1, 0. To find the y-intercept, you let x be a 0. Which equation, yellow or pink, is easier? Yellow. Look. Goes away, goes away, goes away. What do you have? 1 over negative 6. That's negative 1, 6. I want you to stay, if you can, for 1 minute. All I need is 1 minute. Okay? Now I want you to find the non-vertical asymptote. The non-vertical asymptote is a horizontal or an oblique. Biggest over biggest. It is not x over x. It is x over x squared. The bottom exponent is bigger than the top. What's my non-vertical asymptote? Do you remember? Bottom bigger than top. What is it? It's y equals 0. Yeah. There's no oblique. And step number 11, we're going to deal with that next time. Okay? Who followed example 8? Raise your hand, let me see. Who followed it? Okay. If you followed example 8,